In today's lecture, we are going to learn about operations on real numbers. Okay, now we know what rational numbers are and irrational numbers are. Let's just see how we can classify them as a rational or irrational. So check whether 7 root 5 or 7 root 2, 7 by root 5, root 2 plus 21, pi minus 2 are rational or irrational. Solution: 7 root 2 is irrational as root 2 is irrational. So multiple of a irrational number with a rational number is a irrational number. 7 by root 5 is irrational as root 5 is irrational. Whenever we divide or multiply an irrational number by a rational or a rational by an irrational, we'll always get an irrational number. Then we have root 2 plus 21. So wherever we have an irrational number and we add or subtract a rational number, is irrational as root 2 is irrational. And pi minus 2 is also irrational as pi is irrational. Okay. Now, how can we remember what can be rational and what cannot be rational? That is, what will be irrational. There is a simple logic you can remember. Please do not write this in your exams. This is for your understanding. Number 1, rational plus or minus irrational will definitely be irrational. Number 2, rational multiply or divide by irrational or irrational multiply or divide by rational will always be irrational. One condition should be there: the rational number should not be equals to 0, because 0 into irrational, any irrational number will become 0, which will be rational. So the rational number should not be 0. So you can take the example of this as this one or this one, where rational plus minus irrational gives you irrational. Rational you multiply or divide by irrational will also give you an irrational number, or irrational multiply or divide by rational will give you irrational. Like over here, the rational into the irrational gives us irrational, and rational divided by irrational, rational divided by irrational gives us an irrational number. Number 3. Obviously, if you add or subtract a rational, or if you multiply or divide the rationals, you will always get a rational. We are only talking about irrational here. So when we add or subtract irrational numbers, plus or minus irrational, the resultant may be rational or may be irrational. I'll give an example for both. Example, rational plus minus irrational plus minus irrational. Say root 2, 2 plus root 2 is an irrational number, and if I add 2 minus root 2, which is also an irrational number, these two numbers on addition gives 2 plus 2, 4, and plus root 2 minus root 2 cancels off. So irrational plus irrational gives a rational number. This is irrational plus irrational giving rational. Another example, let's take off root 2 plus root 5. This is an irrational number. This is another irrational number. We cannot solve this. This will remain as root 2 plus root 5. The resultant, this whole thing is also irrational. So irrational plus irrational may give rational. Irrational plus irrational may give irrational as well. So this is not fixed. And number 4, irrational multiply or divide by an irrational number may give irrational or may be rational. This is also not confirmed. Let's take both examples. Say root 2 divided by root 5. So we have root 2 by root 5, which is root under of 2 by 5. So irrational divided by irrational gives irrational here. Another example, 2 root 7 divided by 7 root 7 gives 2 root 7 by 7 root 7. Root 7 cancels off, we have 2 by 7. So irrational dividing by irrational giving us a rational. Similarly, if you would have multiplied them, root 7 into root 7 would become 7. So this is again become rational. So if you multiply or divide, we do not say for sure that on multiplication or division of two irrational numbers we'll get back an irrational or rational. We cannot say for sure. We can only find it after solving them. Okay. So this was our first example. Next example, we'll deal with some problems now. Add 2 root 2 plus 5 root 3 and root 2 minus 3 root 3. So solution, 2 root 2 plus 5 root 3 plus root 2 minus 3 root 3. When we add them, we need to take the like terms together. This one that has both has root 2 are like terms. So root 2, 2 root 2 plus root 2 will take them together, and 5 root 3 minus 3 root 3 will take them together. Now on solving them, root 2, 2 root 2 plus root 2. Think of root 2 as x. So 2x plus x, what we get is 3x. Similarly, 2 root 2 plus root 2 will get as 3 root 2 plus 5 root 3 minus 3 root 3. Again think of root 3 as y, say. So 5y minus 3y will get 2y. Over y we choose as root 3. So this is how we'll be solving irrational numbers. We'll consider them as x in our mind itself and we'll solve them. Example 3. Multiply 6 root 5 by 2 root 5. So in the solution, 6 root 5 into 2 root 5. So in this type of question, we'll multiply the rationals. 6 into 2 is 12 and root 5 into root 5 is root 5 whole square. So the square and the square root cancels off. 12 into 5 will get us 60. So this is our solution. Example 4. Divide 8 root 15 by 2 root 3. So solution, 8 root 15 divided by 2 root 3. So 8 under into root 15. 15 can be written as 5 into 3 by 2 root 3. 2 ones are, 2 fours are 8. So this becomes 4. Root 5 into 3 becomes root 5 into root 3. When we separate the roots for multiplication, we write root 5 separately into and root over 3 by root 3. So root 3 cancels off. We have 4 root 5 as our answer. Okay. Some basic things that you need to remember is root under of AB becomes root A into root B. Second, root under of A by B becomes root A by root B. Third, root under of A plus B is not equals to root A plus root B. Whenever in multiplication or division, you can separate the roots, but if you have addition or if you have subtraction, you cannot write them as root A minus root B or root A plus root B. This is completely wrong. So please make sure that you do not do this mistake. Like root 2 plus root 3 will remain as it is. This is not equals to root 5. But root 2 into root 3, when in multiplication you can multiply them. So this becomes root under of 2 into 3, that is 6. Please do not add them. Addition or subtraction is not possible, but multiplication or division is possible in roots. Okay. Now we'll look at some examples where we will simplify some questions. Example 5. Simplify the following expressions. Number 1, 5 plus root 7 into 2 plus root 5. So let's do them one by one. So solution, 5 plus root 7 into 2 plus root 5. So just like we multiply, so we'll multiply them as well. 5 into 2 plus root 5 plus root 7 into 2 plus root 5. So 5 into 2 is 10 plus 5 into root 5 is 5 root 5 plus root 7 into 2 is 2 root 7 plus root 7 into root 5. So 10 plus 5 root 5 plus 2 root 7 plus root 7 into root 5 will become root 35. When in multiplication, we can multiply the components of numbers inside the roots. The second one, 5 plus root 5 into 5 minus root 5. So this is basically of the form a plus b into a minus b. So it becomes a square minus b square. The square and the root cancels off. We have 25 minus 5, that is equals to 20. Third question, root 3 plus root 7 whole square. So a plus b whole square is a square plus 2ab plus b square. So we have root 3 square and the root cancels off. 3 plus 2 into root 3 into root 7 is root under of 21 plus root 7 square is 7. Now 7 plus 3 we get 10 plus 2 root 21. Next one, number 4. We have root 11 minus root 7 into root 11 plus root 7. So a plus b, a minus b into a plus b, that is a square minus b square. So a square, root 11 square is 11 minus root 7 square is 7. 11 minus 7 is 4. So this is our answer. Okay. Next type of questions that we are going to deal with are rationalizing the denominators. Whenever we have any irrational number in the denominator in any of the answer, we'll always solve them and we will put the irrational number in the numerator by rationalizing the denominator. Okay, so rationalize the denominator of, say, number 1 is 1 by root 2. So how do we rationalize this? If there is a root 2, so we'll multiply and divide by root 2. Why are we doing so? Because root 2 into root 2 becomes 2. So the denominator has a rational number, hence we have rationalized the denominator. The irrational number is only in the numerator. The denominator is free from irrational number, hence our work is done. Second question. This type of questions are very important from your exam point of view. 1 by 2 plus root 3. So in this type of question, what we will do is we'll use the fact that a plus b into a minus b is a square minus b square. So we'll multiply and divide by, if there is plus, we'll multiply and divide by minus. So the numerator 1 into 2 minus root 3 is 2 minus root 3 by a plus b into a minus b is a square minus b square, which becomes 2 minus root 3 by 2 square is 4 minus root 3 square is 3, which becomes 2 minus root 3 by 1. 1 if you omit also, if you do not write, it's fine in the denominator if you do not write. Third question. 5 by root 3 minus root 5. So here we had plus, so we multiplied and divided by minus. In this question we have minus, so we will multiply and divide by plus. So root 3 plus root 5 into root 3 plus root 5. If there is minus, we'll multiply divide by plus. If there is plus, we'll multiply and divide by minus. So 5 into root 3 plus root 5 by a plus b into a minus b is a square minus b square. So 5 root 3 plus root 5 by root 3 square is 3 minus root 5 square is 5. So we have 5 root 3 plus root 5 by 3 minus 5 is minus 2. So the final answer becomes minus 5 root 3 plus root 5 by 2. In the standard form, we do not mention minus sign in the denominator. We always write minus sign in the numerator. Okay, the fourth part. 1 by 7 plus 3 root 2. So now we have plus in the denominator, so we'll multiply and divide by minus. So what we had, we wrote it just like that, and we multiply and divide by 7 minus 3 root 2. So 1 into anything becomes that same number. So 7 minus 3 root 2 by a plus b into a minus b is a square minus b square. So 7 minus 3 root 2 by 7 square is 49 minus. Please note that when you have two numbers like this, 3 and root 2, and a whole square out of this one, this square is for 3 as well as for root 2. So 3 square is 9 into root 2 square is 2. Make sure that you do not cancel off the square and the root. That would be wrong. You need to take the square for 3 as well as for root 2. 7 minus 3 root 2 by 49 minus 9 to the 18. So we have 7 minus 3 root 2 by 49 minus 18 is 31. So this is how we rationalize the denominators. The next type of question is a little different. In this, we will try and represent a root under of decimals on the number line. So say a question represent a root under of 3.5 on the number line. Previously we learnt root 2, root 5, root say 8, root 10. Those were all whole numbers or natural numbers. Here we are learning for decimals. Okay. So in this you need to be very careful with your steps. First step is to take the length whatever is given to us. So we are taking .5 as our main scale. So this one is 3.5. Now next what we are going to do is we are going to take one more after 3.5. So after 3.5 we are taking 1 centimeter more. So this one, let's name this as AB. This, the 1 centimeter that we took extra, say this is C. Let's mark this as 1. Let's AB is 3.5. Next what we are going to do is we are going to draw a perpendicular bisector for AC, the whole length AC will draw a perpendicular bisector. To draw a perpendicular bisector, what you need to do is you need to take a length more than half of this one, say this much. This is around half, we'll take a little bit more than half. We'll cut a line in the below the line and we'll cut an arc above the line. Similarly, from A, we'll cut an arc up and one arc down such that they meet with the previous arcs. One we made from C and the other we made from A. So where they meet, now next what we'll do is we'll join them using dotted lines. Okay. So where this cuts this axis, we'll just mark it as O. Say this is O. Now taking O as the center, we'll mark the O as center and we'll make a semicircle here. So we get a perfect semicircle here. Next step, we'll keep this line at P, this point at P, and we'll make a line to the top. And let's say this point we mark it as D. So this BD that we get, this is the value of root under of 3.5. Now since this is not on the number line, this is our number line. So what we'll do is we'll measure this one BD using compass. We'll measure BD and we'll use a dotted line to bring this down. So initially we had not made this line longer. We'll just extend this line a bit. So this becomes our number line. And this point that we get, and this point is basically our root under of 3.5. So B, and say this point is A, B, C, D. We may name this point as E. So BE that we get is equals to root under of 3.5. Since this length was 3.5 and we have not changed the length, we are drawing the same length on the number line like this. So this BD and BE will be equal, and so BE is also equals to root under of 3.5. In this you need to learn the steps, memorize them and then solve them. Please go through the steps carefully. If you have any confusion, go through the video again and try it on your own. If you still have problem, we'll discuss them in the live conference video. Okay. So the last part of this chapter deals with some basics of exponents. So laws of exponents. For real numbers. So some formulae: a to the power m into a to the power n is a to the power m plus n. Second one, a to the power m whole to the power n is a to the power mn. Third, a to the power m by a to the power n is a to the power m minus n. Fourth, a to the power m into b to the power m. The bases are different and the powers are equal, so we write this as ab whole to the power m. Number 5, anything to the power 0 is 1. Number 6, whenever we have anything in fraction, so we can write this as nth root of a. Let's deal with an example. So simplify. Number 1, 2 to the power 2 by 3 into 2 to the power 1 by 3. So we'll get this as same basis, powers will get added, 2 by 3 plus 1 by 3. 2 by 3 plus 1 by 3 is 3 by 3. So we get 3 and 3 cancels off, we get 2 to the power 1. Second part, 3 to the power 1 by 5 whole to the power 4. So this becomes 3 to the power 4 by 5. We'll multiply the powers. Third part, 7 to the power 1 by 5 by 7 to the power 1 by 3. Whenever we have powers like this in division, so powers get subtracted. So 1 by 5 minus 1 by 3. The LCM, this is in power itself. So the LCM is 15. We have 3 minus 5. So we get 7 to the power minus 2 by 15. And the fourth one, the last question, 13 to the power 1 by 5 into 17 to the power 1 by 5. So the powers are same. We'll multiply the bases, 13 into 17 whole to the power 1 by 5. So we get 221 to the power 1 by 5. With this, we come to the end of today's lecture. Please complete all the exercises from your textbook.